Hey everybody, welcome back. Today we're going to do lab number 4. This is another test kit lab where we're going to look at the levels of nitrate and phosphates in a water sample. Now, today for me, I'm going to film 2 labs, one for this week and one for next week. I'm going to do the nitrate and phosphate lab and then the total dissolved solid or salinity lab. And the reason for that is I managed to get a sample bottle here full of water from the Corniche. So this is salt water, ocean water, and I'm going to try to use this today because I just got this sample. And that was a very weird Uber trip. But anyways, so today for me, I'm going to film 2 labs. For you, you'll only see part 1 of this. Again, the nitrate and phosphate kits. So I'll be right back with the nitrate test. We'll do the phosphate test, and that's it. Should be a pretty quick video. Before I actually do the experiment, I guess I should run over the equipment here that's in this phosphate test kit. You can kind of see behind me, through the magic of YouTube and editing, I've already done the dissolved solids lab. That takes a lot of time, but I have this resting here, so just ignore this until next week. But this kit I'm going to use right now with this sample, and it involves a few things. It's a pretty quick test. I wouldn't say it's as accurate as an ion selective test where we would use a Vernier test kit, or not test kit, but Vernier equipment in the lab. An electronic device is basically what I'm saying. This is, a little bit more, it was less precise, more subjective, because the kit involves us using a comparator, a reader, and comparing colors. Think of this like using an indicator or a litmus test versus using a pH meter. So instead of using a meter, I have kind of a color system which I have to go by. So in the kit, there's 2 tests in here. It's pretty easy. I have the phosphate acid reagent along with the phosphate reducing agent. I have a nitrate reagent and then mixed acid reagent. And I'll kind of go over these 4 chemicals as I do the experiments. So the nitrates and the phosphates kind of part 1 and part 2 of this. I have test tubes here, which are measured. Okay, and they're measured because I can put them in this. This is like a reader, and judging by the color of my solution when I do the experiment, it should match something here. So nitrates are over here. It goes from 0.2 to, I think that says 1 parts per million, and the phosphates do the same, 0.2 to 1 parts per million. Okay, and I have to kind of compare them based on the color. So I'll do my best to show that in the camera, but if you can't see it, I'll give you the results. So I'll get things cleaned up, I'll get some gloves on, and I'll do the nitrate test. Nitrates. Well, we talked a little bit about this in class, and we will certainly talk about this tomorrow in class. I think literally the next 2 topics are nitrates and phosphates, so this will mean a little bit more after Thursday's class. But nitrates and phosphates are, typically present and needed in marine ecosystems, but at higher levels they can become a big problem. So nitrogen, this is in water. It's a product of the biological breakdown of the organic nitrogen being produced through the oxidation of ammonia. It's not really toxic to fish, but in high levels, it can really be detrimental to water quality. So nitrates are something that we would measure when looking at water quality. So in marine environments, 0.1 to 0.2 parts per million are ideal. Anything over 50 milligrams per liter, or ppm. Anything over 50 is, unhealthy for lakes, could be toxic to fish. In an aquarium setting, and you can find a lot of this information online because this is something people manage in their aquariums, 10 to 40 parts per million would be poor quality in an aquarium. And I know in the past we've talked about the delicate nature of coral reefs. We talked about that certainly with pH. In coral reef systems, nitrates, they're very sensitive to nitrates. So an acceptable range for a reef system will be 0.25 parts per million, not more than 5. So, you know, some water systems can handle more nitrates than others, but the ideal amount being 0.1, 0.2 parts per million. So we're going to test that today. This goes from 0.1 to 1 ppm. We might see less than 0.1. We could see more than 0.1, so this will be interesting, this test today. So I am going to fill this test tube up, and I'll be right back. So I have this made up or mixed to the 2.5 milliliter line. These test tubes have been used for a while, so the numbers are kind of fading off a little bit, but it is to the 2.5 milliliter line. And the next step in the procedure, it's only a 6-step procedure, which I will share online, but the next step of this is to fill this to the 5 milliliter line and wait 2 minutes. Fill it to the 5 milliliter line with the mixed acid reagent. So I'm just going to fill this up to the 5 milliliter line. The test kit comes with this pipette as well, so it comes with everything you need. Okay, and it says wait 2 minutes. There is also a cap that I'm going to put on this while I wait, so I'll be right back. It's been about 2 minutes, and I have the top on this. It's capped, as you can see, and the next step here is to add 1 scoop. It comes with its own little scoop here of nitrate reagent, and it's 0.1 grams of nitrate reagent. And it mentions in the procedure to make sure you don't add any extra. So, you know, I'm going to scoop and level this off, kind of like, you know, when you're baking, to put this in here. I then have to shake it 60 times in 1 minute and then wait another 10 minutes. Before I do that, it does mention something in the beginning of the procedure that we need to consider for this test. It says that nitrites, so we're testing for nitrates, nitrites can cause serious interference in this test and should be determined separately and compensated for if present. Now, we don't have a nitrite test here, or even back in the lab. This doesn't come with a nitrite test kit. So there's a little bit of error there. We don't have any way to see, or I don't have any way to see right now if there are nitrites in this water. The other thing it says in the introduction is the best results are obtained when the solution temperatures are 23 degrees Celsius. So before I kind of go any further, it'd be nice to check the temperature. This water has been sitting here for hours, so it's reached, you know, kind of room temperature. So this is another little sample bottle I have, again, at room temperature, and I'll just test the temperature of this. And according to this, we are at 23.8. So actually 23.9 when I took it out, 0.8. So we are pretty much on the dot there for the temperature range, close to 23 or 23.8. It doesn't get much better than that. So I am going to add 1 scoop of reagent to this and shake it 60 times and then wait 10 minutes and we'll be back. I might do a little fast forward here, obviously. So I'll see you in 10 minutes. Okay, so it's been 10 minutes. The sample has definitely changed color. The test kit comes with this standard to compare it to, and even without using the reader here, you can see the difference in colors if I hold them side by side from water, clear water, and the solution, the sample water. The sample, you can tell, is clear but kind of pinkish, almost looks like the end point of a titration. So now what I do is I put it in this reader and compare it to the levels of parts per million. We go from 0.2 to 1, and it does say in the procedure that the result I get, I will multiply it by 4.4, which I'm going to get you guys to do. Pretty easy. So in here, I just have the regular sample. It says to not, put this into direct sunlight. I have a lamp on in the background, but I'm not going to do any extra lights. So I don't know if you guys can see that. In the middle is my water. It's not my sample. And you can see it's not quite the color of the 0.2, but it's definitely, it's nowhere near this. It's a little lighter than the 0.2. And like when I say a little lighter, there is no color to this whatsoever. So when I do the same thing with my sample from the Corniche, again, I don't know if you guys can see that, but it definitely resembles one of these colors. And it's certainly not as dark as the 0.4 or the 0.6 or the 1. It's closer to 0.2. And if I hold this up to the light and look at it, yeah, it's very much close to 0.2. I looked at this at about 5 minutes in, and I thought it was less than 0.2. But looking at the colors now, it is definitely matching that 0.2 on this reader. So the reader is saying 0.2. The lab manual or the lab instructions say now take this result and multiply it by 4.4, and you will get your parts per million of nitrate in the sample. This is actually a pleasant result because typically in the lab, when we test the aquarium water and we test the tap water, we don't get results like this all the time. So this is, I'm very interested and happy with these results. So I'll clean up, more gloves on, and get set up very quickly to do the phosphate test. It's the same as this test, just with different reagents, but still the same mixing and weighting. So I'll be right back with the phosphate setup. Well, it's time to do the phosphate test. So this is very similar to the nitrate test, just a few different reagents and measurements. So the first step is add your sample water to the 10 milliliter mark. The next step is then use the 1 milliliter pipette here to add the acid reagent, cap, and mix it. We don't have to wait any time. So once I've done that and mixed it, I will use a new clean and dry spoon. This is another spoon in the kit to put the phosphate reagent in. And that's it. I think it says to wait 5 minutes. So here we go. So I'm just going to mix this around. I still see some of the reagent in there, so I will cap and invert a few times. It doesn't say how many times. It just says cap and mix until dissolved and then wait 5 minutes. So I'm going to do this a little bit off camera, and I'll be back in for you a second. For me, I'll be back in 5 minutes. Well, it's been 5 minutes, and this isn't nearly as exciting as the nitrates test. I didn't see much of a color change. So you can see this with the sample of water, like the standard sample, and then the sample of ocean or Corniche water. Now I will, of course, put it into the reader. I'm going to use the other side of the reader. Okay, so I'm using this side now, and let me stand up and look at it. I'm not seeing much of a difference. Let me move in the kitchen here, see if I can get a different light and see if it's closer to one of these results. The interesting thing about this reader is the 0.2, for me, the way it looks is essentially clear and colorless, similar to the standard water sample and this water sample. Now, I wouldn't be confident saying that this is 0.2 ppm. So here in the nitrate test, it was definitely 0.2. The color matched almost perfectly. Here, it is matching the 0.2, but so does the standard water sample. So for this one, I would be confident giving it a range of phosphate parts per million between 0 and 0.2 or less than 0.2. So again, we do have a small amount here. I am seeing a match, but the match does match the standard. So this would be less than 0.2 ppm. Okay, it's certainly not the 0.4 or 0.6. Okay, so there's the results from the phosphate test. Well, so that's it for the experiment. The procedure for the phosphates test doesn't mention multiplying it by any numbers. So our results for the nitrate test, all of this will be in your lab quiz, but it was 0.2 ppm on the reader, which we then multiplied by 4.4. The phosphate test was less than 0.2 ppm, so 0 to 0.2 ppm, and we don't have to multiply that by anything. This is a test specifically for orthophosphates. So that is the results that we're going with. That's it for the lab. I am going to film another one for next week because I do have the ocean or Corniche water that I want to test for dissolved solids. But that's it for now. So I'll see you next week. Bye-bye.